All right, class. This is Mr. Eggleston, and this is a continuation of lesson 4.7, graphs of inverses for algebra 2. I should put A2 here for make sure you understand you're looking at algebra 2. And here's to check your understanding. Hopefully you tried this. It says let h of x equal, what is that? X minus 1 squared plus 3. All right, it says sketch the graph and identify the domain and range of h of x. Well, remember how this works. This is in vertex form, a quadratic. So what you should realize is that the vertex occurs at 1, 3. So 1, 1, 2, 3. There's the vertex. Now, drop, this is all from our last unit, drop a vertical line down through the vertex. That's our axis of symmetry, AOS, and that is going to be x equals 1, all right? Now, the idea, as a refresher, is from this point, the vertex, we go 1 to the right. Since this is squared, this is an x minus 1 squared, we go 1 to the right. 1 squared is 1, and we go up 1. Okay? Likewise, we go 1 to the left. 1 squared is 1, and we go up 1. I did this a lot when we were looking at different types of functions. Then we go 2 to the right, 1, 2. 2 squared is 4, and you go up 1, 2. Oh, I just lost my train of thought there. 1, 2, then we go 2 squared is 4, you go up 1, 2, 3, 4. And you get this, 1, 2, 1, 2, 3, 4. Right there. 1, 2, 1, 2, 3, 4. If we go over 3, 1, 2, 3, 3 squared is 9. You go up 9 and it goes off the grid. So the parabola will look something like this. Let's see if it snaps. It doesn't snap, darn it. All right, so there's your parabola. Okay. Identify the domain range. Well, the domain it's going to be all real numbers. Because remember, no matter how far we go along the x-axis, you can always square whatever number you're at and get another real number. So it'll just keep getting bigger and bigger, and it goes both ways. So it's all real numbers. The range, however, it's going to be restricted because the range is all the outputs, the y values. And as we go along the y-axis, we begin right here at 3, and then the graph is only going above 3. So the range is going to be y is greater than or equal to 3. We can write this in set notation because I'm starting to switch over to it as bracket 3, comma, infinity, parentheses. Okay? The bracket, which is this squared off thing right here, just means it's or equal to. That means it actually equals. Can be equal to 3, and the parentheses says it's doesn't quite equal it. It can't equal it, but it can keep getting closer and closer. All right, again, you can just leave it like this, and you'll be fine. Write an expression for the inverse. Well, the inverse, step by step. This is y now. You switch x and y. So this is going to be x equals y minus 1 squared plus 3. And now switch x. Okay, I already switched x and y. All right, remember I changed h of x to be y, so this is y equals x minus 1 squared plus 3. So that helps because we're going to be switching x and y. All right, so now solve for y. Subtract 3. Okay. Take the square root of both sides. And since it's a squared, and you're taking a square root, you get the square root of x minus 3, but you can't forget you get two possible results. You get a positive result or a negative result. Okay? And then, on the other side, when you take the square root of a squared, when you take the square root of a squared, these two cancel out, and it leaves you with just y minus 1. So adding the 1, you end up with y equals 1 plus or minus the square root of x minus 3. Now, this is the inverse. We went through the steps. Inverse of f of x. So we would just change y to be with this f to the negative 1, because that's the official notation for the inverse of f. And we write it like this. Okay? And this is the inverse. Notice we get, for any value of x that you get a real result, you'll get two possible answers. One plus that number, one minus that number. So for each input, you get two outputs. That is not a function. So the inverse is not a function. This is the inverse of f of x. It is not a function. Okay, it says identify the domain and range of the inverse. Well, the domain of the inverse, let me use yellow, just to, in contrast to the original function. The domain is just going to be the range of the original, and the range is y is greater than or equal to 3. Here's the range of the original function f of x. So this becomes the domain, except for y becomes, since we switch x and y, it becomes x is greater than or equal to, 3? Yeah. And we would write it like this, 3, comma, infinity, boom. All right? The range is just the domain of the original function. Here's the domain. So since the domain is all real numbers, the range of this is all real numbers. And we would write it like this in set notation. Again, don't panic over that set notation. I'm going to start using it in class and stuff to get you used to it. The sideways 8, this right there just means infinity. Means it keeps going forever. And you got negative infinity to positive infinity. All right? Now, is the inverse of h of x a function? Explain. No, it's not, as I've been saying. Because to find the inverse, we had to take a square root. We got plus or minus. That right there makes it not a function. I should say the inverse is not a function. Is not a function. Okay. Because you get a positive and a negative solution. You could also have said, because the original graph up here, right there, is not 1-to-1. It doesn't pass the horizontal line test. Okay? It is not a 1-to-1 function. Or it doesn't pass the horizontal line test, which is the same as the vertical line test to prove a graph is a graph of a function. The horizontal line test is to prove that the inverse of that graph that you're doing the horizontal line test on would be a function. Okay. Now, what am I doing? Okay, so the velocity of an ant in inches per minute is given by the graph of v of t shown below, 4, 0 to 4, where t is in minutes. Identify the x-intercepts. The x-intercepts are right there and there. Determine these values in the context. So the x-intercepts are 0, 0. I'm going to write them as ordered pairs. And 3, 0, comma 0. Okay? Interpret these values in the context of this problem. At t equal to 0 and 3, the ant, because this is the graph of the velocity, is not moving. Think about the graph of the inverse of v of t. How would you label the horizontal and vertical axes? Well, you just switch them. So this one down here for the horizontal of minutes becomes the vertical on the inverse. So the vertical would be minutes, and the horizontal would be velocity. In inches per minute. Identify the y. Notice that they say the y-intercepts of the inverse. Well, the y-intercepts of the inverse, remember, since the inverse you just flip x and y, so the x-intercepts of 0, 0 and 3, 0, x, these are from the original, from original, okay, they become, on the inverse, well, the 0, 0 is still 0, 0, but, and 0, 3. And then it says interpret these values in the context of the problem. Well, according to this, the ant would have 0, when the ant has 0 velocity, it would be at time t equals 0 and t equals 3. The ant has 0 velocity at t equals 0 and t equals 3. Then the last question, for which values of t is v of t equal to 8, what does this solution represent? Well, to do this, you look at the original graph, you find out where 8 is, and it's a little blurry, but 8 is right here. And it's right there. Oops, it's a little off. But I think you can tell that that's 8 right there. And so they touch right there and right there. So when it says for which values of t is v of t equal to 8, it'll be at t equals 1, and t equals 3. What does this solution represent? It would represent at times t equal 1 and 3, the velocity of the ant would be equal to 8 inches per minute. Okay. And that is the end of this discussion. There you go. Have a good day.